Good day everyone. So we are here to present our secondary data entitled Environmental Assessment of Upland Soil Erosion using 137 CEs or Cesium 137 and in the Banga Watershed, Bohol, Philippines. So this study assessed the medium-term soil redistribution. So this study was based to Oliveris et al. 2016. So they have focused with two sites with conservation and technical land which is without conservation. So in site 1, the gross erosion rate have 13.15, then the gross deposition rate is 32.21, then the net soil loss or gain have negative 22.23 which is net gain. Then the soil erosion classification, then it was classified by POW is light erosion. And site 2 have typical upland with gross erosion rate have 22.23, then gross deposition rate have 10.63, then the net soil loss gain have 2.62 which is net loss. Then the soil erosion have moderate erosion. So they also measured the offsite environmental impact. So the parameters is TSS, the total suspended solid, SDR, the sediment delivery ratio. Then the location of this study is the Wahig River or the upland area. Then the TSS, the measured value is up to 782.0 milligram per liter. Then the sediment delivery ratio, which is calculated for the site 2, so same location, and the calculated ratio is 0.20. So today we are going to discuss about the parameters used in this study. So we have 5 parameters used. First is the 137 Cesium inventory. So it is the foundational tracer for measuring soil movement. It provides a reliable long-term 40 to 50 year average, which is superior to short-term plots. So how it works, so how 137 Cesium inventory works. So researchers measure 137 Cesium in soil sample across a landscape. Lower than expected levels indicate soil loss because 137 Cesium was removed with the soil. So while higher levels can suggest soil deposited from upslope. So why it matters? Using 137 Cesium allows scientists to estimate long-term erosion rates over decades far beyond what typical field measurements can capture. So we have here gross erosion rate. So the second parameters used in this study. So it quantifies the total soil detachment. This is the key metric for comparing against national sustainability standards. Example is the tolerable soil loss limit. So why gross erosion rate is important? So it tells us how much soil is being stripped from the landscape due to natural forces like rainfall, runoff, and human activities like farming, deforestation. High gross erosion rate is a red flag. It suggests severe landscape degradation. So the third is the net soil loss gain. So it is the ultimate metric for assessing sustainability. It determines if the form system is stable or degrading. How this differs from gross erosion? Kaning we have net loss and net gain. Gross erosion only shows soil loss. Net soil balance considers both loss and deposition. So critical this
parameter is also critical. So why it is critical? So this helps decision makers know not just where soil is eroding, but where soil is being lost permanently or temporarily removed and later deposited. So next is lastly is the TSS and SDR. So TSS, which the total suspended solids. So these two these two parameters measures the offsite impact directly linking on farm erosion to the resulting water pollution. So how this parameter measured? Water samples are filtered and the solids retained in the filter are weighed. More particles equal higher TSS or total suspended solids. So why it's used? High TSS in rivers implies that soil erosion upstream is actively happening. Those particles are being washed away and carried by water. So what it tells us in erosion studies, links soil erosion to water quality, increase sedimentation downstream, and indicate poor land management upstream. So for SDR, so for SDR, it defines that is the proportion of eroded soil that actually reaches a drainage outlet like stream or watershed outlet. So it bridges field scale erosion with watershed sediment yield. High SCR means more eroded soil is making it into waterways, increasing downstream sedimentation problems. Low SCR means much of the eroded soil might be redeposited before reaching streams.
And now we discuss the comparison to the Philippine standard. So tolerable soil limit, loss limit. So the Bureau of Soil and Water Management standard for the sustainable soil loss is typically set at 10 hectare per year, and the measured cross erosion rate of 22.23 hectare per year at the non-conserved site exceeds this limit by over 120%. So, so the measure of soil erosion is more than double to the Philippine standard sustainable limit. So, meaning the area is experiencing severe and unsustainable soil degradation, which is the area is filled and not fit in the standard. So while in the water quality standard of DNR or DOUT 34, so the DNR water quality standard for conventional pollutants limit suspended soil to less than 60 milligram per liter. So the record of TSS value of up to 782.0 less than 60 milligram per liter in the river exceeds the standard by over 13 times. So confirming they have facing a severe siltation and pollution. So in the conclusion, unsustainable degradation, common upland farming lead to unsustainable soil degradation or cross erosion of 22 hectare per year. So failing to the meet of Philippine tolerable limit by over 120%. So the upland farming practices are causing soil erosion for beyond acceptable in the Philippine limits, indicating serious environmental degradation. So in the critical pollution, this land use in the direct cause of critical pollution in the river system, which sediment levels of TSS severely violating national water quality standard. Because of these farming methods, the river is extremely polluted with high sediment levels that violate national water standard. So in the proven solution, so the success of conservation measure in the site 1 in achieving a net soil gain provide clean
and data-backed evidence that a solution is viable and effective. So, in the conservation practices on this site one, at another site is successfully improved soil condition. It's proving that sustainable solution exists and effective. So, in the urgent need for action, so the study confirmed an urgent need for sustainable water and water management to protect both Bohol's upland farm and its downstream water sources. So that's all from our group. Thank you everyone for listening.